Welcome to my channel Tech World with Preet. In this video, we are diving into the world of security and exploring the important concepts of authentication, authorization, and microservices security. We want to help you to understand how to build a strong and secure foundation for your digital projects. In this course, we will cover the following topic: exploring authentication and authorization mechanisms. We will understand the basic understanding of security. What is authentication? What is authorization? With the real world example of flight booking system. Understanding the concept of OAuth2 and OIDC. We will see the overview of OAuth2 and we will also learn the introduction of OpenID Connect, which is an authentication layer built on top of OAuth2. The next we will see understanding JWT. We will see the JWT structure and usage. Along with that, we will see how the JWT validation and security considerations are taken into account by discussing the process of validating and verifying JWT with the best practices. Next, we will cover Introduction to Microservices Security. We will identify the unique security challenges posed by the microservices architecture, including service-to-service communication, access control, and data protection. After that, we will have a look on Keycloak concepts. We will see the introduction to Keycloak, an open source identity and access management solution. We will explore its features including user management, single sign-on, and role-based access control. We will be considering flight booking application project to understand these concepts. We will be considering flight booking application for most of our use cases to understand the different concepts what we are trying to explain in this video, including authentication, authorization, OIDC, OAuth2 and Keycloak. Now let's begin with exploring authentication and authorization mechanisms. In the context of flight booking system, security involves two important aspects: authentication and authorization. Let's use an example to explain these concepts. When a user arrives at an airport, they encounter an initial security checkpoint. Here, an officer verifies the user's identity by examining their passport or any other form of identification. These steps represent authentication, which establishes who the user is and confirms their identity. Once the user identity is authenticated, the officer proceeds to ask for the user's ticket. By checking the ticket, the officer determines the user's authorization, specifically where they are allowed to go within the airport premises. This authorization could be related to boarding a specific flight, accessing certain areas, or utilizing particular airport facilities. To elaborate further, the officer might inquire about the user's destination and the flight details, such as the gate number or the departure time. By doing so, they confirm that the user is authorized to board the specified flight and enter the corresponding departure area. This authorization steps ensure that the user has necessary permission to access the desired flight and associated services. I hope with our previous example of flight booking, you have understood very well what is authentication and authorizations, which are building block for basics of security. Let's now understand the overview of OAuth2. OAuth stands for Open Authorization and it's an industry standard protocol that was developed for authorization between services, and this protocol is right now in version 2. That's why it is usually called as OAuth2. OAuth2 is widely adopted and has become the de facto standard for authorization frameworks. It provides improved security, flexibility, and usability compared to its predecessor OAuth 1.0. OAuth2 allows application to obtain limited access to user resource on a remote server on behalf of user without requiring the user's credential to be shared within the application. OAuth2 provides a standard way for users to grant permission to third-party applications to access their protected resources such as profile information, photos, or documents which are typically stored on a server. The key actors involved in OAuth2 protocols are resource owner, client, authorization server, and resource server. In the flight booking system, let's try to understand these actors. So the resource owner in this scenario is the user who owns the protected resources, which could include their flight bookings, personal information, or payment details. So the resource owner is typically the individual who is booking the flight or the account holder who is accessing the booking system. The client represents the application that seeks to access the user's resources. In this case, the client can be the flight booking system that needs to interact with the user's flight booking, such as mobile application or a travel aggregator website. Authorization server. The authorization server is responsible for authenticating the user and issuing access token to the client. In the flight booking system, the authorization server could be an identity provider or an authentication service that verifies the user identity and grant access to user flights related resources. It handles user authentication process and ensures the user's consent before issuing access tokens. Resource server. The resource server hosts the protected resources, which in this case are the flight related data and services. It could be the server that manages the flight booking database or API endpoints, providing access to the flight information, booking details, or payment processing. Along with this, now let's see some of the key concepts of OAuth2, including access token, authorization code, and refresh tokens. Delegated authorization. Delegated authorization is the core concept of OAuth2. It enables user to grant permission to a client application, which is called as third-party application or client, to access their protected resources on their behalf without revealing their credentials. Access tokens. Access tokens are the key elements in OAuth2 for providing authorization. Once a user grants permission to a client application, the authorization server issues an access token. This token acts as a credential that the client can present to the resource server to access the protected resources. Access tokens are typically short-lived and have an expiration time. Authorization codes. Authorization codes are used in OAuth2 authorization flow. When a user grants permission to a client application, the authorization server redirects the user to consent page. If the user agrees, the authorization server issues an authorization code to the client application. The client then exchanges this code for an access token. The use of authorization code adds an extra layer of security by keeping access token confidential between the client and the authorization server. Refresh token. Refresh token provides a way to obtain a new access token without involving the user. They are long-lived tokens. They are issued alongside the initial access token. When an access token expires, the client can use the refresh token to request a new token from the authorization server. This allows for seamless and continuous access to resources without requiring user intervention for reauthorization. OAuth2 offers several benefits, including enhanced security. OAuth2 helps improve security by allowing users to grant limited access to their resources without sharing their credentials with third-party applications. User control and consent. OAuth2 puts user in control of their data and resources by requiring explicit consent before granting access to their information. Simplified integration. OAuth2 provides a standardized framework and protocol for authentication and authorization, making it easier for developers to integrate third-party applications and services into their own systems. Scalability and flexibility. OAuth2 supports a wide range of client types and grant types, enabling it to accommodate various use cases and scenarios. Single sign-on capabilities. OAuth2 can be used to implement single sign-on, allowing users to authenticate themselves once and access multiple applications without having to re-enter their credentials. Separation of concerns. OAuth2 separates the authorization process from the application itself. This allows application developers to focus on their core functionality without having to handle user authentication and authorization internally. Third-party integration. OAuth2 promotes integration between different applications and services. It allows developers to leverage APIs provided by various platforms and enable the exchange of data between systems securely. Overview of OIDC. OIDC stands for OpenID Connect. It is an authentication layer built on top of OAuth2, adding identity-related features to the authorization framework. OIDC provides a way for clients such as web or mobile applications to verify the identity of end users based on authentication performed by an authorization server. The key feature and components of OIDC includes identity provider, which is called as IDP. This is responsible for authenticating users and issuing identity tokens. It is typically an authorization server that implements OIDC. ID token. ID token is a JWT, which is called as JSON Web Token, that contains information about the authenticated user such as their unique identifier, name, email and other claims. The ID token is digitally signed by IDP and can be used by client to verify the user's identity. User Info Endpoint. The User Info Endpoint is an API provided by the IDP that allows client to retrieve additional user information after authentication. The client can make a request to this endpoint, providing the access token, and receive a response containing the user's detail. Discovery Endpoint. The discovery endpoint is a well-known endpoint that the client can use to discover information about the OIDC provider, such as its supported feature, token endpoints, and public keys used for signature verification. Authentication flows. OIDC defines several authentication flows, including authorization code flow, implicit flow, and the hybrid flow. This flow determines how the client obtained the ID token and access token from the IDP. Let's see an example how OIDC can be used in flight booking system. User authentication. When a user visits the flight booking system, they are presented with an option to sign in or register using the existing OIDC identity provider account such as Google or Facebook. OIDC authentication flow. The flight booking system initiates the OIDC authentication flow by redirecting the user to the IDP's authorization endpoint. The user is then prompted to authenticate themselves with their IDP credentials. The next step is ID token issuance. After successful authentication, the IDP generates an ID token, which contains information about the user's identity, such as their unique identifier, name, and email address. The ID token is digitally signed by IDP. Next is ID token verification. The flight booking system receives the ID token from IDP. It verifies the signature of ID token using the IDP's public key, ensuring its authenticity and integrity. User information retrieval. If needed, the flight booking system can use the user's ID token to request additional user information from IDP's user info endpoint. This allows the system to retrieve attributes like user's profile picture or other relevant details. Authorization and booking. With the verified identity and necessary user information, the flight booking system can authorize the user to access and interact with the booking functionality. The flight booking system can create bookings, store them securely, and associate them with the user's account. OIDC offers several benefits, including identity verification. OIDC provides a standardized way for clients to verify the identity of end users. Client receive an ID token from IDP which contains verified user information, allowing the client to trust the user's identity. Single sign-on. OIDC supports single sign-on, enabling users to authenticate themselves once with the IDP and then access multiple applications without needing to provide credentials repeatedly. User information exchange. OIDC includes the user info endpoints, which allows client to retrieve additional user information beyond what is included in the ID token. This provides a standardized method for obtaining user attributes such as name, email address, and the profile picture. Federal identity. OIDC supports federal identity, enabling users to authenticate using their existing accounts from popular identity providers such as Google, Facebook, and Microsoft. This simplifies the user registration and logging process for the clients while leveraging the security measures provided by IDPs. Enhanced security. OIDC builds on OAuth2 security features and incorporates ID token verification mechanisms such as digital signatures to ensure the authenticity and integrity of user information. Standardization and interoperability. OIDC provides a standardized protocol and set of specifications, ensuring interoperability across different systems and platforms. Client and identity providers can adhere to these standards, making it easier to integrate and exchange identity information. Scalability and extensibility. OIDC is designed to be scalable and extensible, accommodating various client types and authentication flows. Understanding now the JSON Web Tokens. JWT stands for JSON Web Token. It is an open standard for securely transmitting information between parties as a JSON object. JWT are commonly used for authentication and authorization purpose in web application and APIs. JWT consists of three parts: a header, a payload, and a signature, separated by dots. Here is a breakdown of each part. The header contains metadata about the token and cryptographic algorithm used to secure. It is typically specify the token type and hashing algorithm used for the signature. Payload holds the claim or statements about the entity, for example user or the system, and some additional data. Claims can be categorized into three types: registered claims, public claims, and the private claims. Signature. Signature is created by combining the encoded header, the encoded payload, and secret key known only to the server. The signature ensures the integrity of the token and allows the recipient to verify its authenticity. The server can recompute the signature using the same algorithm and the secret key to validate the token. JWT offers several benefits like stateless and compact. JWTs are self-contained, meaning they carry all the necessary information within the token itself. As a result, servers don't need to store session information, making JWT stateless. They are also compact, making them efficient for transmitting data over the networks. Authentication and authorization. JWTs are commonly used for authentication purpose. Once a user logs in and their identity is verified, a JWT can be issued containing the relevant claims. Server can then trust the JWT and grant access to the protected resource based on the claims within it. Interoperability. JWT are based on JSON format and can be easily parsed and understood by various programming languages. They can be used in different systems, making them interoperable across platforms. Security. JWTs can be digitally signed to ensure data integrity. The signature protects against tampering and verifies the authenticity of token. Extensibility. JWT allow for inclusion of custom claims, making them flexible and extensible for various use cases. We can verify our JWT tokens in this site. This is a jwt.io site. So here you can see two options. On the left side there is an encoded version and on the right side this is a decoded version. So for this encoded version, this is our token. You can see here this token consists of three parts. The first part is with the red, then a dot operator, after that the pink color, and then the dot operator followed by the blue color. So if you see in this decoded section, the first part is the header. The header will show you the red color, which will having the specific information related to algorithm and the type. So the type is JWT and the algorithm we are using is HS256. Then the next part is the pink color. So for this pink color, here is the actual payload which is used. In my case, I have shown you the example with sub, name and IAT. So we can add multiple information in our payload data. And the last option is verifying the signature. So for this verifying the signature, blue color is used. And here it is having a combination of base code URL of header. So the header is the first part. It will do the encoding of base 64 code URL. Along with that, it will also do the base 64 URL encoder for payload. And then here it will give you the 256-bit secret. And finally we will able to see the secret base 64 encoded format. So this is how we can verify our token in jwt.io to understand better. The next topic we will be covering is Introduction to Microservices Security. Microservices architecture brings numerous benefits in terms of scalability, flexibility, and independent deployment of services. However, it also introduces specific security challenges that need to be addressed to ensure the overall security and integrity of system. Let's explore security challenges in microservices architecture. Distributed authentication. In a microservices environment, authentication becomes more complex due to the distributed nature of services. Each microservice typically handles authentication independently, which can lead to challenges such as ensuring consistent authentication mechanism across services, managing user identity and session management across multiple services, and finally implementing secure authentication protocol to prevent unauthorized access, authentication and access control. Authorization in microservices involves managing access control and permission across multiple services. Challenging in these areas include defining and enforcing fine-grained access control policies for different microservices and their endpoints. Along with that, it will ensure consistent authorization mechanism and policies across the entire system. Along with that, implementing secure and efficient methods for propagating authorization decisions across services. Data protection. Microservices often handle and exchange sensitive data, making data protection crucial. Challenges in this domain includes implementing secure communication channel, ensuring proper encryption and decryption of sensitive data. Along with that, implementing proper data access control and minimizing the data exposure to only authorized microservices. Monitoring and logging. With multiple microservices involved, monitoring and logging become essential for security and troubleshooting purposes. Here the challenges includes implementing centralized logging and monitoring solution to gain visibility, correlating logs and events across microservices to identify and respond to security incidents, ensuring secure handling and storage of logs to prevent unauthorized access. Now let's move on to the new topic, Keycloak concepts. To simplify the authentication process, we will use an authorization server called Keycloak. Keycloak is an open source and identity and access management solution that provides authentication and authorization, and it allows you to secure your application by managing user entities, enforcing access control policies, and providing single sign-on capabilities. Keycloak offers several benefits like centralized identity management. It provides a centralized platform for managing user identities, roles, and permissions. The next one is authentication and authorization. It handles the authentication process, including various authentication mechanisms such as username, password, social logins, and federated identity providers. It issues access token and verifies them to grant or deny access to the protected resources. The next one is the single sign-on. Keycloak enables single sign-on, allowing users to authenticate once and access multiple applications without having to re-enter their credentials. This improves the user experience by reducing the need for repeated logins and simplifying access management for users. Federal identity and social logins. Keycloak support integration with external identity providers such as SAML and OpenID Connect. Keycloak also supports social login options like Google, Facebook, etc., making it easier for users to sign in using their social media accounts. Security access control. It allows fine-grained access control by defining roles, permissions, and policies. Multi-factor authentication. Keycloak support additional security measures like multi-factor authentication, adding an extra layer of protection to user accounts. Developer-friendly integration. Keycloak provides libraries, adapters, and client SDKs for easy integration with various programming languages and frameworks. It also offers extensive documentation, community support, and an active user community, making it developer-friendly and ensuring a smooth integration process. Keycloak allows us to outsource the configuration of authentication and authorization to its platform, relieving us from implementing the authentication mechanism manually in our microservices. By integrating Keycloak into our project, we can define the authentication and authorization rules centrally. This means that when a client wants to access our microservices, they will need to go through Keycloak first to verify their identity and obtain the necessary permissions. Let's explore some key concepts and factors related to Keycloak. Rearms. In Keycloak, a rearm is a self-contained security environment that represents a separate domain or application state. Rearms isolate users, roles, and applications, providing a way to organize and manage security boundaries. Clients. Clients in Keycloak represent applications or services that interact with the Keycloak server for authentication and authorization. Clients can be web applications, mobile apps, or backend services. Keycloak provides various client types such as confidential, public clients, with different authentication flows and security considerations. Client credentials. Client credential is an OAuth2 grant type supported by Keycloak. It allows client to obtain access tokens directly from the Keycloak server using their client credentials like client ID and the client secret. This grant type is typically used for server-to-server communication where the client application needs to authenticate itself to the server. Tokens. Tokens play a crucial role in Keycloak's authentication and authorization process. Keycloak issues different types of tokens, including access tokens. These tokens are presented by clients to access protected resources on behalf of the authenticated user. Access tokens contain information about the user and their assigned roles and permission. ID tokens. ID tokens are JSON Web Tokens that provide information about the authenticated user. They contain user attributes and can be used for user identification and verification. Refresh tokens. Refresh tokens are used to obtain new access tokens without user interaction. They have a longer lifespan and can be exchanged for new access tokens once the original token expires. This is the Postman API, and here in the authorization section we have different option to configure. So let's say we want to configure for OAuth2. So here we have to provide the type as OAuth2 and here we need to create the token. So once we will create this token, we have a option to use that as a current token. So let's see in detail what this configuration of new token are and what are these types. This refers to the name or identifier for the token you want to configure. It helps you differentiate between different tokens if you have multiple configurations. You can provide any name here. I have provided the name as token, which is the actual token value that will be obtained after successful authentication and authorization. Grant type. It specifies the type of grant or authorization flow you want to use to obtain the token. The most common grant types are authorization code with PKCE, implicit, password credential, and the client credential. For our use case, we will be using client credentials. Access token URL. This is the URL where you can send the request to obtain the access token. For example, this one will be your security integrity server. In my case, I have used the Keycloak. So in Keycloak, I have done the configuration to configure the rearms, and this is the rearm detail we have provided along with the token. In our next video, we will see how to configure these details. Client ID. It is a unique identifier assigned to your client application by OAuth2 provider. It is used to authenticate and authorize your application when requesting the access token. In my case, I have provided the client ID as Spring Cloud ID, which we have configured in the Keycloak. Client secret. This is a confidential value that serves as a password for your client application. It is known only to your application and the authorization server. The client secret is used for client authentication using the token request. So as you can see, this is some encrypted value. Scope. The scope defines the level of access and permission your application requests from the user. It specifies the resources or actions your application wants to access on behalf of the user. In my case, the scope I have defined is offline access, which typically grants long-life access to the resources even when the user is not actively using the application. Client authentication. This refers to the method used to authenticate the client application when requesting the access token. It can be either client secret basic, which involves sending the client ID and client secret in the authorization header, or it can send this detail as a parameter in the request body. I have used the option as send as basic auth header. These points are specific to configuring OAuth2 for obtaining a new token. Keep in mind that the values provided in our example like access token URL, client ID and client secret are for illustration purpose only, and it may vary on your actual OAuth provider or the setup. This is the official website of Keycloak. Here you can see in the download option to install manually Keycloak on a Windows machine. Alternatively, you can have an option to use a Docker to set up the Keycloak. If you prefer to download and install Keycloak manually on your machine, I recommend watching a separate video mentioned in the link in the comment section. It demonstrates the step-by-step process and it will guide you through the installation using zip file, ensuring that you have Keycloak up and running locally. We will cover how to configure Keycloak using Docker in our next video. We will see the actual integration of flight booking system with OIDC, Keycloak and OAuth2 using Spring Boot microservices architecture in our next project.